Assalamualaikum warahmatullahi wabarakatuh. My name is Abdul Muhaimin bin Abbas from EE242. Will present to you my final year project titled Passive Forward Scatter Radar using LTE signal for drone detection and classification at different angles of movement. For the introduction, I will explain about radar. Radar divide into two parts, which is monostatic and bistatic. For monostatic, the transmitter and the receiver at the one place. For bistatic, the transmitter and the receiver at different places, as you can see in the figure. In bistatic, there's an application named forward scatter radar. It's also used the bistatic, which is the transmitter and the receiver at different places, but it is include 180-degree bistatic angle. For more explanation, I will explain in my case study, which is passive forward scatter radar. I use passive signal, which is LTE signal, as my transmitter, and then my passive radar as my receiver. So when the target crossing the baseline, 180-degree of bistatic angle. My problem statement and objective. For first, my problem statement is spy activities, which is it is a bad habit for drone activities. So my first objective is understand and identify the passive forward scattering radar works. My second problem is control improvement. Monitor drones movement at banning area. As we know that Malaysia government has some certain area for banning area, such as Putrajaya. So my second objective is to detect the Doppler signature of the drone at different angles using LTE signal. My last problem is hacking tower communication. Drones as a tool for jamming communication signal. So this is my last objective, which is able to classify the Doppler signature of the drone at different angles using MATLAB. For my methodology, the first one is experimental site. First experiment location is at MAIPS, located at Sedang, Selangor. Tower base station as the transmitter and passive radar as the receiver. The distance between the transmitter and the receiver is 176.78 meter. So my second location is at Teluk Kemang, located at Port Dickson, Negeri Sembilan, where the transmitter and the receiver distance is 531.22 meter. And this is the last location, which is at Kampung Nyalas, located at Melaka, where the transmitter and the receiver distance is 1020 meter. For my second methodology is drone angles movement detection. Okay, first is transmitter. We have the transmitter and we have the passive radar receiver. So the target is a drone, and then the drone will crossing the baseline. When it's crossed the baseline, there is a Doppler signature, as I shown in this figure of the waveform. When the transmitter and the receiver facing each other, there is a bistatic angle which is 180 degree. This is we call passive forward scattering radar. So I will explain my angles movement. Of course, the first one is vertically, means the drone move upwards and downwards, crossing the baseline in front of the passive radar receiver. My second is horizontally, which means the drones fly from the left to right and right to left. And my lastly is descending 45 degrees downwards and ascending 45 degrees upwards. This is my angles of drones. For my last methodology is data processing. First is data collection, where the data is collected at 3 different places. The data collect in raw data in time domain 20 seconds. So the next is data cropping, where the data will be cropped only the Doppler signature. And the third is data denoise. It will reduce the unwanted signal. And then the fourth is power spectral density, where the time domain converts into frequency domain. This is principal component analysis, where the analysis where this is used training data group into their own cluster, such as vertical up grouping into their own cluster, vertical down grouping into their cluster, so on goes to the horizontal right, horizontal left, descending 45 degrees and ascending 45 degrees. So the last is data classification, which means it will give the percentage. For the result, I will explain at my first. For the time domain, it's called Doppler signature, where when the cross-section area is increased, so the time taken for the target crossing the baseline will increase, shown in this figure where the horizontal right and horizontal left has the highest time taken. This is due because the highest cross-section area. Vertical up and vertical down has the lowest time taken. This is due because the low of the cross-section area of the target. Move to the PSD, where this power spectral density is a conversion time domain to frequency domain. As we know, the frequency equation, where the increase of the time taken, the decrease of the frequency. So in this Doppler frequency, the horizontal right and horizontal left have the highest time taken. So Doppler frequency is have the lowest frequency, as shown in this figure. For PCA, each angle group into their own cluster. So MIPS has very good detection for the drones. Thus, the percentage for this classification is 100% for each figure A and figure B. For the next result is at Teluk Kemang. This is in this time domain. Horizontal right and horizontal left have the longest time taken. This is due because the cross-section area that I mentioned earlier. The lowest is the vertical up and vertical down of the time taken. We move to the PSD, where the frequency equation, when the low time taken, so the frequency will be high, shown in this figure, where the vertical up and vertical down has the highest frequency Doppler. This is due because the shortest time taken need to crossing the baseline. Based on the PCA result, the red cluster and the black cluster overlap on figure A. Meanwhile, in figure B, the red cluster overlap with the black cluster and the red cluster overlap with the blue cluster. This is due because the distance between the transmitter and the receiver is further compared to the MIPS. Thus, the percentage of this classification is 95.87 and 94% for figure A and figure B respectively. The last result is at Kampung Yalas. For the time domain, this is also follow the trend of MIPS and Teluk Kemang, where the horizontal right and horizontal left have the highest time taken. This is due because the cross-section area crossing the baseline is high. Vertical up and vertical down also have the lowest time taken. For the power spectral density, it's also use the same equation where the frequency 1 over t, where the time taken is increased, so the frequency will be dropped. As shown in this figure, horizontal right and horizontal left have the lowest frequency Doppler. Based on this PCA result, cluster red and cluster black overlap each other, and then of cluster black and cluster blue overlap. Meanwhile, in figure B, cluster red more overlapping with blue and black, which means there is more overlapping happen here. This is due because the distance between the transmitter and the receiver is much more further compared to MIPS and Teluk Kemang, 1020 meter. This is why The percentage is 88.99% and 89.18% for figure A and figure B respectively. For the conclusion, the different angle movements of drone can be detected by using passive radar system. 6 angles of the drone, which are vertical up, vertical down, horizontal left, horizontal right, ascending 45 degree and descending 45 degree, have their own unique Doppler signature. In the nutshell, all the angle movement of the drone successfully classified into their own cluster. Even the distance between the transmitter and the receiver is further, but the passive radar still can detect the target. That's all from me. Thank you. Assalamualaikum warahmatullahi wabarakatuh.